Okay, so we're in chapter 5. We're starting in chapter 5. So this is section 5.1. And we're going to start in working with perimeter and area. And we're going to take the ideas that we came up with in our opener and kind of expand on those a little bit. So for perimeter, we decided that a good definition of perimeter was how far around the outside. If we're talking just in everyday terms. And if we look at the word perimeter, peri means around, and meter comes from measure. So it's measuring around is where the root of the word comes from. And we decided that we also needed a closed shape for perimeter to make sense. We're talking about a closed shape. And our definition is, our more formal definition is the distance around the outside. And what we normally do for our different shapes, the rule that we're going to follow is we just add up all the sides. And for something like a circle or some other shape, we might need to come up with some different kind of formula, but we're doing essentially the same thing. We're adding up all the sides. So let's look at a quick example. If we had some kind of shape like this, and we know that this is 9, this is 7, and this is 8, and this is 10. All we're doing when we're working with the perimeters, we're just adding up all the side lengths. It's pretty straightforward idea. So our perimeter is just 9 plus 7 plus 8 plus 10, and if we add all those up together, we get 34 units. And in this chapter and the next couple of chapters, we're going to need to be careful with how we use our units. When we're talking about perimeter, we're talking about a length. So we always measure length in units, in centimeters, in inches, in meters. When we talk about area, we talk about square units, square inches, square miles, square feet. And when we talk about volume, we'll be talking about cubic units, cubic inches, cubic meters, cubic feet. So in this chapter, in the next couple of chapters, we're going to be kind of picky about how we do the units. So when we're talking about a length, when we're talking about perimeter, we're talking about units, inches, meters, centimeters. If it doesn't give us a units, we just say units. Now let's do an example that requires us to do a little more work to get to our answer. So here's our picture. And we'll call this shape WXYZ. And we know that WXYZ is a parallelogram. And this side is 7, and this side is 11. how do we figure out the perimeter of this parallelogram? Jay?
You add 7 to WZ and 11 to WN.
Okay, so we add 7 to WZ. So you're saying label that side as 7? Okay. So we're going to put a 7 here and an 11 here. And why are we doing that?
Because they're equal.
If it's a parallelogram, the opposite sides are the same. So our perimeter then is just adding up the sides. Is 7 plus 7 plus 11 plus 11. And that gives us 36 units. So for some problems, we'll have to figure out, they won't give us every side, we'll have to figure out some of the missing sides using what we already know about shapes, about parallelograms, about squares, about rhombuses. So we'll have to figure out some of the information. Any questions about what we're doing here? All things that we've seen in one way or the other before. We're just kind of building a foundation for the rest of the chapter. Let's talk about area. What do we mean when we're talking about area? Perimeter is how far around the outside. So what would be a kind of an everyday definition of area? What are we working with?
Space inside.
The space inside. I think that's perfect. The area is the space inside. So perimeter is how far around the outside. Area is the space inside. Does it make sense to talk about the area of a shape that's not connected, that's not closed? No. Haley says no. So our shape has to be connected or closed. So we're going to make our definition just a little more. It sounds more complicated than it really is. But what we're talking about is, excuse me, how many squares of some certain size will fit inside? And what I mean by that is if we have a rectangle, let me draw a rectangle here. And we say this is 2 units by 4 units. What is the area of that rectangle? Area equals 8 square units. What this definition, what we're saying here is if we divide this into 2 parts this way, and I didn't do that quite perfectly. Let me do it this here. There we go. If we divide it into 2 parts that way, and see how close I can get here. Let me go a little further here.
Mr. Beeman, are you
Yeah.
recording yourself right now?
Yes.
I'm on YouTube.
Your face.
So it's not perfect, but what this is saying is that we can fit 8 squares inside this rectangle. That's what we mean by this definition. And depending on the size of the square, our area would change depending on our units. If we measured in inches, our shape is going to have more square inches inside than it does have square feet. But we're really trying to figure out how many squares of a certain size will fit inside a shape. That's what we mean when we're talking about area. Now, what if we have an irregular shape, something that's not a nice rectangle? How can we figure out the area of some irregular shape? What could we do? Divide it up, and then add all the pieces together. Find the area of each piece and add them all together. So we have an irregular shape, we divide it up. That's what we want to do. And we'll do a couple of examples in just a minute where we have an irregular shape and we want to figure out the perimeter and the area where we have to divide it up. So for an irregular shape, we divide it up. So let's go to our, before we move on, anybody have any questions? So like I say, we're building a foundation here today. The stuff that we're going to talk about for the chapter. So let's talk about the perimeter and area of a rectangle. That's going to be our first specific shape. So we'll have you have a space right at the beginning of your flip book where it has a rectangle where we can write our formulas here. It says quadrilaterals, and we'll talk about some other quadrilaterals in a little more detail later in the chapter. But for today, we're just worried about rectangles. So here's my rectangle, and we know this is a rectangle because we're saying these are all right angles. And I'm going to call this side B and this side H for base and height. The area. How do we find the area of this rectangle? Base times height. Doesn't matter which side we call the base, doesn't matter which side we call the height. We just have to multiply the length of one side going this way by the length of one side going this way. And for this rectangle, we would say that's B times H. There is base times height. How would we find the perimeter of this rectangle? Could we write a formula for the perimeter? We could say 2, you're thinking of, okay, there you go, you're right. So 2 times base plus height, or if we distribute here, we could say 2b plus 2h. 2 bases plus 2 heights. And if we think about what we talked about before, we said that the perimeter, and we add up how far it is around. We have a base length here and one here, so we have 2 of those. And we have a height here and a height here, so we have 2 of those. So we have 2 bases plus 2 heights gives us our perimeter. So there's our first formula. The perimeter of the area of the perimeter of a rectangle is 2b plus 2h. Now this one you don't really have to memorize because all this is doing is adding up all of our sides. So if you want to remember a formula, you can remember this, but also remember that all we're doing is adding up all the sides. So that could be those are your formulas for that first page of your flip book. And I would recommend that you label one side of your rectangle B and one side H if you wrote your formulas like this, so you know what we're talking about. Any questions so far? All right, let's look at a couple of examples, and then we will be set. So we're going to look at an irregular shape and another problem that's kind of important because we'll see a lot of problems like that. What if we have a shape that looks like this. My sides are kind of crooked there, aren't they? Get it better. There we go. That looks a little better. And now with these kinds of, in this chapter, it's important to remember that we need to go by what the picture, what the diagram shows us, not by what it looks like. So I'm going to say that this side is 8, this side is 6, this side is 10, and this side is 12. And for this, we want the perimeter and the area. So how are we going to find the perimeter and area of this shape? Anybody have an idea?
You could chop it into rectangles.
So Jalen says chop it into rectangles.
Well, like the 8 top one, just make it even rectangle.
Here?
Yeah.
Okay. So let's just divide it up. That's what we said earlier, is we would divide it into pieces. So let's cut this off here. And then we can use the information that we have here to try to figure out the other sides.
Wait, is the 8 the little line or the big line?
8 is this little line.
Sorry.
All right. So if this whole side is 10 and this piece is 8, what does that leave for this part? 2. So, like I said, the drawing, you have to go by what the diagram tells you, not by what it looks like. So this side is 2. And then if this whole side is 12 and this part is 6, what does that leave for this part? 6. So that part has to be 6. Now we can find our perimeter. Our perimeter is going to be 2 plus 6. We have all the outside parts now. Plus 8 plus 6, I'm going around clockwise. Plus 10 plus 12. And if we add all those together, we get 2 and 6 is 8. 8 and 8 is 16. Plus 6 is 22. Plus 10 is 32, plus 12 is 44. And my units here, are they going to be units, units squared? Units. All right, and my area. So to find my area, I've divided this in pieces. So let's look at, we need to find the area of that rectangle, the red rectangle, and the area of the blue rectangle. So what's the area of the blue rectangle? 8 times 6, or 48. 8 times 6, and we're going to add that to the area of the red rectangle. What's the area of the red rectangle? This side is 12, and this side is 2. So 2 times 12. So we're going to get 48 plus 24 equals, we add those together, 72. And for this units, unit squared, unit squared. You can say unit squared or square units. Either one works. So if we have an irregular shape, we can divide it up. Divide it up however, whatever's the most convenient way to divide it up, and use the information that we have to figure out missing parts, and then we can find the perimeter by adding around the outside. We can find the area by adding up the areas of the different parts that we've divided up into. Questions on that? All right, one more example. We're going to see a lot of this kind of problem in this chapter. So for this problem, we have two rectangles. We have one here and one here. And this, the outside, the bigger one, is 12 by 10, and the smaller one is 6 by 4. And we want to find the area of the shaded part. So how can we go about finding this the area of the shaded part here?
You just do 12 times 10, and then you subtract 6 times 4.
So Andrew says we do 12 by 10, 12 times 10, and we subtract 6 times 4. So what we're doing here essentially is, it's like we had a big piece of carpet, a big piece of cardboard, something, and we're cutting a hole out in the middle there. So we're taking away that part in the middle. We're taking it out. So we subtract that. It might help you to write for a problem like this, even if you're not sure exactly how to do the calculations. We could say this is the big part minus the small part. And if you had some complicated problem and you didn't know how to calculate all the numbers, and on your test you wrote that the shaded area is big minus small, I would give you some partial credit for that, because you understood what we were doing with the problem. You just didn't, maybe you didn't necessarily know how to find the area of a particular shape. I would give you some partial credit for writing the area is big minus small. So let's calculate. 12 times 10 is 120, minus 6 times 4 is 24. So 120 minus 24, we get what? 96. And our units? Square units. Units squared. And also, if you were working on a problem and you weren't sure what the units were and you wrote inches squared or centimeters squared, even though it didn't tell you that, I wouldn't count that wrong. As long as you understood that it was square units, I would be fine with that. Any questions? All right, homework. Let me write those down. We're on page 299. All right, there you go.